Now that we know how to work with both JUnit and Selenium, it's time to put the two together. Going into this section, it's important to remember that both JUnit and Selenium are simple libraries. JUnit allows us to run methods as tests in a special context that allows for assertions, which are often simple checks of equality. Selenium is just a library that manages an automated browser instance, allowing us to send data to and read data from the browser. However, by writing our Selenium scripts inside of JUnit test methods, and by checking data from the browser using assertions, we can achieve something quite special: automated user testing. It turns out these libraries are well suited for one another. Selenium requires a setup phase in which the driver is initialized, as well as a teardown phase where driver.quit is called. These are perfect for JUnit's @before and @afterAll lifecycle methods. And @beforeEach and driver.get can be used together to make sure every test starts from the same base URL. That means it makes sense to separate tests into classes that correspond to groups of controller methods. That organization makes sense because Spring controllers represent our application's user-facing features. And with Selenium, we want to test our app as a simulated user. Grouping related functionality in the same test class is only natural. When we think of user actions we'd like to test, we often think of them as high-level interactions on specific pages. For example, clicking the login button on the home page or submitting a search term on the search page. But so far, the way we've interacted with Selenium is much more arcane. Find the element with the correct CSS selector, send it keystrokes, then execute a submit action, and our code reflects that complexity. Tests are meant to be legible, and it would be much better if we could simply call a method to submit a given search term. That would be much clearer to read and understand. Selenium's page object is a built-in tool for accomplishing this. Much like a Spring component, we can define a class with web element fields that can be injected by the WebDriver. We can configure how the WebDriver searches for the elements with annotations, and then we can add utility methods that perform common actions on those elements. For example, we might implement a Google page object with a search input element and a list of result elements, as well as a method called search, which performs the search action. That means a JUnit test for this action could be as simple as writing the following. The actual code would probably be slightly different, but this captures the essence of how legible we want our test to be. In the next video, we'll look at this in practice and see how we can use it to define reusable test scaffolds for our templates.